button. I'm going to make sure we're showing up on our live stream. And we'll wait a minute before we really get going in our conversation. I think we're already a minute early as well. And if anyone is already here, say hello in the chat and maybe say where you're watching from. That's always fun. And if you also want to throw in maybe why you're interested in learning more about graph databases and RAG, it's always really cool to kind of hear about what people are building in the audience as well. So you can say hello in the chat. Oops. I meant to type in the chat, but I opened up VS Code.
Oh, well, yeah, you could just you're gonna script the hello into the chat. That's
yeah,
slightly over-engineered.
Yeah, where's everyone tuning in from? I'm streaming from Seattle. I know, Jason, where are you streaming from today?
Coming in from San Diego.
Nice.
And I guess, since, we're at May 1st, we're just a couple days from, magical May 4th. So I got my Star Wars t-shirt on here, touting Tatooine State Park, or I guess not really a state park, more like a galactic park. But yeah, if anyone wants to post their favorite Star Wars episode, I'm always curious which movie is people's favorites. Which one's your favorite, Sage? Have you watched? I'm guessing you watched.
Oh, I've seen all of them. Yeah. I want to say that it's probably like episode 5.
5 would be Clone Wars? Wait, so
no,
5 is
no. 5 would be the second one made.
Oh, right. Yes, in which order are we talking about? So Empire Strikes Back, right?
Yes.
Okay. Yes. Yeah, Empire Strikes Back. That one was definitely my favorite growing up. It's still one of my top favorites, but I think as an adult, my current favorite is Rogue One with
sorry, mine is too. That one is so good. I kind of forget that it's like falls in the whole episodes. I love that, and I also loved Andor, like the show.
Yes, yeah, great series. I'm looking forward. Yeah, looking forward to season 2. Yeah, you're right, because it's kind of like not quite an anthology, but it's not part of the main Skywalker timeline.
I don't know if it has an episode title or if it's just like a prequel.
Right, yeah, because
if anyone knows.
yeah. Because I think Disney was trying to do a whole sort of like tangential series, right, with Rogue One and also Solo, and then
yeah, that's right.
Decided to backtrack.
Yeah, Rogue One was awesome. All right, so I think let's go and get going. And again, if anyone wants to post their favorite Star Wars movie or series in the comments, definitely do so. And we'll get going with the chat here. So again, welcome everyone. My name is Sage Elliott. I'll be the host for today's Union Fireside Chat. At Union, we build tools around AI orchestration and making data and ML pipelines more robust. You can check out everything we're doing at Union.ai. A lot of people know us from our open source work with Flyte, Flyte, and Pandera. You can check out, again, go to Union.ai. You can find links to those as well. Always check out our open source. And if you're looking at it on GitHub, give us a star. We always appreciate that too. But today's chat is not about us. We have Jason Koo from Neo4j with us. Welcome, Jason.
Thank you, Sage. Hello, everyone. Sage says, I'm from Neo4j. I'm a developer advocate here. And Neo4j, if you haven't heard of us before, we're a graph database company. We're kind of the OGs of this space. And we'll be talking about what a graph database is and why you might want to use it.
Awesome. Yeah, and this is a fireside chat. It's, kind of a short conversation. Feel free to say hello and ask questions in the chat. If we have time to get to them, we can definitely do that. But with that, let's go ahead and get on with the conversation. So, Jason, before we go even deeper into like graph databases and RAG, which is what we're going to be talking about today, is advanced RAG techniques with graph databases for large language models. And this is a question that actually keeps coming up a lot in conversations that I've been a part of. Is like, people keep hearing about graph databases and they can use them to build better RAG systems, and that's what we're going to talk about today. But before we do that, could you provide a little bit more in-depth introduction and let us know a little bit about your background and maybe a little bit about what you're currently working on, even though I'm sure we'll dive a little bit deeper into graph databases and Neo4j later.
Sure. Yep. So my background into dev advocacy, which is kind of similar to all advocates, is a very, very organic, tangential way. So I started off actually in video production, and in one of my last jobs in that field was basically when like Getty Images and iStocks was kind of booming, this company wanted to get into the same space. So I was helping them cut up a bunch of videos and getting them prepared for being resold on, on the internet. Unfortunately, there was no system for after we had the files cut to making it ready for distribution onto a marketplace. All we had was like an Excel sheet with file names and like, okay, we've stored this clip on this drive, and it's like, okay, well that's I didn't know much about database in the whole infrastructure for supporting this in the past, but I was like, okay, this is not going to work. So I spent a year learning how to build a database that basically tracked all these assets and then tied it to kind of a front office system so that when clients came, we could pass it on to them and basically get everything ready up for when a website was ready to ingest that data. So that was my kind of dipping my toes into tech. That was also the same time when iPhone, the public development kit became available. So I jumped into that, and very quickly I told someone, a friend of mine up in Portland, that I was doing this, and then he came back like the next week. I was like, "Hey, how's that going?" Because I've got a client who wants a Facebook clone. This is Facebook 1.0, right? And I was like, "Sure, I can do that." And so that kicked off my development career, starting off with iPhone and SDK development, and over time gave a lot of talks, did a lot of presentations, and then discovered advocacy is its own job role. So I kind of switched over, and I've been doing this ever since. So that's
Awesome.
the long short.
And if I remember correctly, were you at a computer vision company for a while too?
Yes, yeah, right. Which is how we met, right? Because we're both
Yeah, I think
in the
so. We were
computer
both
vision
working
space
at computer
for a
vision
while.
companies. Yeah.
Yes. So one of my early advocacy jobs was working for this computer vision company based out of here in San Diego. And yeah, I dived a lot into Python. That was when it really sunk my teeth into Python and IoT devices. And so I'm still playing around with those stuff on the side. Every year I try to build an IoT Halloween project. Not sure if I'll be able to do it this year, but it's always like one of those things I look forward to.
We should definitely talk more about that at some point, because I also always want to build little IoT and like robotic projects, and having someone else also doing it, I know helps motivate me.
Oh yes, yeah, we should. Let's do something. Yeah, that'd be fun.
All right. So our main topic today is, like we mentioned, advanced RAG techniques with graph databases for large language models. Before we get into the advanced RAG technique part for LMs, can we talk a little bit about graph databases in general? What is a graph database, and how is it different from other types of databases?
Right. Okay. So the biggest difference between a graph database and other database types is the relationships. So the relationship data between two other entities that is stored as part of the permanent data store along with entity data. Right. So in other databases, you have lots of records, right? So you got lots of people storing like names, social security numbers, etc., and maybe events, right? Like so, like today at this time, there's this Union fireside chat, and a list of other events, and then maybe skills, right? Like Python, computer vision, blah blah blah. So these are all kind of separated records, separate tables. And if you wanted to find relationships between that data in other databases, you'll have to use like a foreign key or a lookup table, something to sort of bridge that relationship gap. In a graph database, that relationship is its own record type, right? And think of it as a high efficient, highly performant lookup table because the relationship will know basically the hashes of the two nodes that it connects. So when you're doing traversal queries, like finding shortest path or finding multiple branching, basically pulling a subgraph of graph data, it will do it very, very quickly, right? Whereas, say, if you're using an SQL database, you'll have to do many, many joins. And as you do more joins with a never increasing larger part of your data set, the whole query gets much, much slower, right? But for a graph database, it can query these sort of branches very quickly with minimal degradation in performance. There's basically no loss in performance until your data set is substantially huge. So yeah, so that in a nutshell is a graph database. If you wanted to visualize it, I like making the analogy to a crime map that you would see in a TV show or a movie, right? You have different pieces of data, right? You have a suspect, you have a like a possible weapon in a place, receipts, and they're all connected by these red lines, right? Except the red lines also contain data, right? Like this receipt was used to purchase the murder weapon, and you can have all sorts of data in there. And so when you have data in the relationships, you can also basically weight it, right? So if you come from an ML neural net background, you'll see that a graph data store, a knowledge graph, is very similar in shape to a neural network, right? So you have the additional advantage of being able to run machine learning algorithms very easily on graph data, as well as run graph data science algorithms on top of graph data. So like page ranking and shortest path calculations, those have to be done on data in a graph format, right? There's no algorithm that gives you shortest path that's not in a graph form. So those types of algorithms now become very easily accessible when your data is stored in a graph database. Okay, I think that they covered a pretty good breadth of it.
I think so. That's a really good explanation, I think. So you have these nodes in a graph, and there's the connections to basically other nodes, like you were saying. I like the visual explanation of a crime scene, or whether connecting different pieces to it, and then those kind of become, like you said, they can be weights, just like a neural network. So you have kind of almost like this underlying metadata or something. I don't know if that's the term for it, but with those
Uh,
nodes.
yes, yeah, we call them properties, right? So just like so every node, which is like an entity record in every relationship, can also contain properties inside a property graph database, which Neo4j is. So just tangentially, there are also different kinds of graph databases. Earlier type is known as kind of an RDF type, which is just a bunch of triples. In which case, each of the nodes actually don't contain their own properties. They just have a relationship to another node that is the property. So you can imagine that's a much more dense kind of graph, but it is also a graph data store type.
Gotcha. Awesome. Very cool. Thank you for the great explanation. All right. And before, again, we get into tying graph databases with RAG, if people don't already know, I assume a lot of people here listening probably already know, and it's been a topic that's come up a lot in previous fireside chats. But I guess what is RAG, and then we'll go into how we can tie graph databases into RAG.
Sure. So RAG stands for Retrieval Augmented Generation, and I think it came out of a paper back in 21, I want to say. And so what RAG is trying to address is large language models are known for hallucinating, right? That's kind of problem number one. Problem number two is they have a knowledge cutoff, right? So past the date that they were trained, they really can't give you any sort of input or advice on that. So, and also they have very small context windows, or at least the earlier LLMs had small context windows. Current ones have quite large ones. So what RAG does is it pairs a large language model with a database. And usually in the paper, it's namely using a vector database, which we'll come back to in a bit, but database in general. So what that does is it allows you access to a much larger data set than what can fit in a context window. And the context window is basically the kind of the short-term memory capability of large language models, right? So you can feed it so many words, tokens, and they will give you answers. But after a certain amount, after it caps, it'll forget what happened before, right? So it's basically like short-term memory. Okay, so pairing with a database gives an LLM long-term memory, and it gives it access to potentially like timely data, right? So any data that was after its training cutoff, if the data is stored in that database, it now has access to that. And by kind of framing the LLM within the data provided by the database, you can limit hallucinations. Basically telling it like, hey, if the data isn't in the database, then don't make up something. Just say like you don't know. right? So RAG is a great technique for addressing those things and also making a lot of like private data available for use by an LLM.
Right. I think a lot of companies, especially if they're using something like GPT, they don't necessarily want to fine tune or send their data there. They can have their data living in their environment, pull in GPT, and give it some of the context for basically completing a query that someone's like asking a question about. And also, tracing is another big thing I think too that I've seen a lot of people talk about with RAG. Like you bring in the documents for your project, and then when it answers a question, if you build it right, sometimes you can actually link out to like how it came up with that answer, and then you can go like look at the docs and verify it if you need, which is pretty cool.
Ah,
Uh,
yes, yeah, right.
all right, so now that we know a little bit about graph databases and what RAG is, how can graph databases be used to improve these RAG techniques?
Right. So I don't know if this technique has an official name, but I've seen it listed as just like graph RAG, otherwise just RAG with knowledge graphs. So the advantage of pairing graph data with, say, unstructured data like vectors. So I'll talk about vectors real quickly. Um, so vectors or using vector stores is a way of taking semantic data. So take like a description, something from like a PDF or a description of an event. So there's a bunch of data in there, but it is not structured, right? Now, taking a large language model and turning it into an embedding. So you can take this block of text and you can turn it into a mathematical representation of that text, right? And then you put it into a vector database or a vector store, and it sits in this high dimensional space with other data that's put in there. And when you write a query, the query gets turned into basically a vector representation, a mathematical representation of that question. And then that basically number block is compared with all the number blocks inside a vector database. And whichever pieces of data is most similar to it is pulled up and referenced as an answer to the question. Right? So that's um, generally how like a vector store works and how RAG with vectors work. Now, there are some limitations to this, right? Without monkeying around with metadata, you're not generally going to be able to answer multi-hop questions, right? And also, if the answer is not written in a description inside the document, then you also will not be able to get an answer from it. And also, generally speaking, normal databases like Neo4j or any database in general can give you aggregate data, right? So you can query for things like, give me your total number of records, give me records that are similar to this. You can, do all these very deterministic queries and get answers from databases, which don't work too well with a general vector database, right? You can't write a query without touching metadata, going like, hey, how many records about blah do you have, right? Because that involves sort of a math calculation that other databases can do quite well, but other databases don't do unstructured data very well, right? Like finding a semantic meaning within a block of text. So, okay, so back to, okay, so vector is great for unstructured data, and graphs are really great with semi-structured or even structured data because of the relationships it has been, if it's been given this information, the relationships between, say, a given document and other things like authors, publisher, maybe keywords that may be tied to other things, right? So what a lot of folks do in graph databases is they'll often put in an ontology inside the graph database. And an ontology, you can think of it as a hierarchical organization of categories. So different domain spaces have different ontologies, right? Like medical, gene history, family history, different types of technologies, and which ones are related to what. So when you have those ontologies inside a graph database, and you put in your private data that maybe has really complex descriptions, then when you use the vector search, you can pull up the pieces of content that semantically match the query. But because that data is also connected in a graph, you can also pull up um, extra ancillary data, contextual data related to that thing. So not only can you ask a question, say of like, let's see, like let's do like a supply chain or kind of like a product um, database. So like, say you're looking for like, I want to know what my best performing or best selling shoes are that are of this type and elicit these kind of feelings. So a vector can pull those exact products, but then you can go like, okay, now which other products is this product sold with? So when people buy these red shoes that make them feel fantastic, what other things are often bought with it? With all the data connected in the graph, it can very easily pull records of all those other sales, aggregate those, and then give that back to you, right? So this is kind of a fun demo that we ran at Microsoft Fabric last month, was asking like which two products are most often sold together and who buys the most of these combinations, right? That is quite a few hops. It's a multi-hop. That's a kind of a many-to-many question. And Graph with the vector was able to pull out those answers and present that.
That's awesome. That's very cool. So, using it to bring that knowledge into something like a large language model, just gives you almost just gives you more that you can either query on, or maybe the large language model will decide this information is relevant and kind of provide a and like, oh, do you also want to know who bought these shoes, even though maybe that wasn't exactly your question, but it has that knowledge, and then it could kind of prompt you maybe to dig a little bit deeper.
Yeah, totally. So it both gives you more context to whatever, the original document that you might have been pulled, but also gives you access to sort of tangential things, right? So it's like that game of uh, the Kevin Bacon game, 6 Degrees of Kevin Bacon. So you can find answers to those types of questions uh, stemming from that original piece of data that was pulled with like a vector search or keyword search or any other type of search.
You should make a 6-degree chatbot if you haven't already with Neo4j.
Yes, actually, this is something that I've heard come up every once in a while when I'm at certain meetups, right? Like, well, actually, there's a project here in San Diego that some folks have been wanting to restart, which is a startup San Diego map. And so in the past, they just kind of track like which startups and where and who are part of them in different parts of San Diego. But what they really wanted to get to was when someone wants to connect with another startup, right? Like either they're looking for a job or they're looking to invest in a particular startup. Like how do they get matched to a startup that's most relevant to them? And this is actually a really good graph problem, right? Because if you tie everyone not only by the type of the startup, but like who works there and what skills they have, as long as it's all in a connected graph and you're coming in at this point, you just go like, okay, I'm looking for someone who's like really great at Python, has some computer vision experience, and is either looking for work or currently works in a related field. You can query that in a graph database and get like a page ranked answer fairly quickly. Um, so, anyways, I do talk to them like, maybe you guys should use a graph. But you know, people are used to the technologies that they're most comfortable with, and they've been, I think, tackling it with a traditional SQL database, or
Right,
trying to.
right. And I see some questions in the chat. We'll get to them in a little bit. I'm going to wrap up some of our other questions still on the RAG part here first. So we talked about how you can use a graph database to pull in data for RAG. Can you share a use case or an example, maybe where you've seen like graph databases improve RAG, or another example of like something you've built, or if you've seen a customer, you don't have to name the customer or anything, but maybe like a use case of implementing a RAG solution with a graph database?
Sure. So I've done mostly internal experiments with folks here. So again, that example from Microsoft Fabric was probably my favorite one. We have done some other experiments using Edgar data, so SEC filing data. So every company that files for being on the stock exchange has to file with the SEC, and they file just a whole heap of PDF docs. And so we basically took a subset of that, put it into a graph database, and did a combination of vector and a retrieval query combination. So what we're doing here and what you can do is you run the query and it runs the vector search first and basically pulls up some candidate answers, right? And then from those answers, you can run uh, a cipher, which is the syntax language for querying graph databases, and query basically around that pooled piece of data. Like, okay, looking around here, what other information that we're interested in might be of value to the LLM, and sort of pull that out and then give the whole thing to the LLM to synthesize a complete answer. And it's given like better answers. As all things with LLMs, it's always, depending on the questions and how dense you make the knowledge graph and how the quality of the both the question and the answer. Lots of variables. But in general, we've got more satisfying answers doing it that way than doing a vector only approach.
Awesome. Awesome. And so I see people, so this might be relevant to some of the questions people are asking is like, oh, how do I learn more or go get started? What advice would you give someone thinking about implementing graph databases into their AI applications? And are there any like significant challenges they should be prepared for when getting started?
Yes. So if you want to learn more, definitely go check out Graph Academy. So there's a team here, Adam Cowley and Martin. Both of them work super hard, constantly working on new and also improving existing courses. So it's a completely free online course, and it's basically an interactive course, right? So as you're spinning up these different tracks, you'll learn some things and ask you some questions, but it will also spin up a sandbox version of Neo4j, so you can directly play around with it, right? So they'll give you all the commands that you can run, and then you can tweak those commands if you want. You can do basically whatever you want with that sandbox. But basically, if you follow along, you'll learn how to use a graph database, and there are a couple courses already for using LLMs with graphs. So uh, Adam has actually built a chatbot inside Graph Academy, and one of the courses is showing you how you can do that, build your own.
That's awesome. I want to go and start playing around that because I haven't used that with an LLM so far, which I think would be really fun. And I shared the link in the YouTube chat, and also it's in the description. So if you're watching this later, it should be in the YouTube description. And if you're watching this anywhere else, you can go to neo4j.com, go to the Learn menu, and there's a Graph Academy listed right there, and you can go find all these courses, which they look really cool. So I'm excited to dive in myself. All right. And then, can you tell us a little bit more about kind of what Neo4j is doing besides these awesome educational courses? Or is there anything else coming out soon that you want to like give a shout out to or have people check out?
Yes. So before I forget, at the end of the year, we run our large annual Graph virtual conference. So right now the CFP is open. So if you are familiar with graphs or you have an idea that you really want to kick off and need an excuse to get ready for within this year, submit an idea, submit a paper. But basically, what will happen is there'll be 4 tracks this year, talking about different elements of using graph. So one is on Gen AI, of course. One's on data science. The other's on like production tools and other elements. Oh, I just noticed. Am I frozen for you, Sage?
Yeah, I think it might have been the Apple thumbs up thing.
Yeah, I might have thrown that off. Okay, hold on. Let me.
I can hear you fine though. I can hear you fine.
Okay, let me just unplug and plug it back in and see if that'll reset it.
No worries. Audio is the most important thing.
That's right. Yeah, which is a big thing in film production. Okay, so it looks like this is out, but fortunately, I've got a backup here, which I will see if this will work. Boop. Let's see, connect, hopefully. All right. Okay, so I got my backup up, and now I just got to. Oop.
I see
All
you.
right, so that is my Facebook cam, and question is settings. Here we are. Okay, all right. So sorry about that. So I've got for anyone who's in video production, I've got a high quality DSLR to laptop connector, and then I've got a lower quality one for just like meetings and stuff. So the high quality one, which is the one I was on earlier, I think after about 30 minutes that I've noticed recently, somehow it just kind of like tanks out. So anyways, I just switched to the lower quality connection. Okay, so we were talking about
the graph conference, I think.
Graph conference. Oh yes, yeah. So nodes. So yes, so it'll happen end of this year, November, if I got my dates right. But yeah, if you want to submit a talk, that is open. Otherwise, definitely look out for the agenda and all the talks that will be popping up.
And I think someone asked a question about that specifically: is do they have meet and greets in person? I assume it's an in-person conference.
No, so Nodes is virtual, so that one is not in person. But
Got
we do host or kind of co-host various events. So the next event I'll be at is actually we'll be up in San Francisco, and we'll be doing a joint event with Weaviate. So we'll be showing how to use a vector store with a knowledge graph with Neo4j. So that will be June 11th at GitHub's office. I'll pass a link to you, Sage, for you to post up.
Yeah, I'll
But if
update the description later with any links that you share afterwards. So.
Okay, perfect. But yeah, even on our homepage, our events page does a pretty good job of listing all the in-person events that we do. And so we're always going places. We're always somewhere. So wherever you are, very likely we'll have an event close to you if you want to jump in and learn more. Talk with us and get to learn more about graphs.
Yeah, and there's a lot of great like workshops that you all constantly do as well. Like someone was asking a question in the chat, like, is there a place to go, learn how to do this the right way, etc. And I think that, I know there's recordings of a lot of those workshops and you have the Graph Academy, but there is something really nice about going to live workshops and like being able to ask questions and go through a project with other people. And so definitely check out all the events Neo4j is doing. They're one that I go check out almost every week to see what cool stuff is coming up, and I include it in like lists of cool events. So definitely recommend keeping up, staying updated with the Neo4j's events. It's really, really good stuff if you're looking to do state-of-the-art graph database work and get that live training. Go check it out for sure.
Please do. Yes.
One last question from me, and then maybe we can potentially answer any in the chat. There's actually a lot going on in the chat today, which is awesome. But I might have lost some of the cool questions that other people had. But what are you looking forward to most in the AI field? Maybe that isn't a graph database.
Yes. So the agentic workflows that are being developed, right? So I think everyone had, or not everyone, but a lot of folks have kind of hit the kind of the wall of what you can do with semantic search, right? Like straight up the easiest sort of vector solution. And now we have a whole set of advanced RAG options that are appearing. And then on top of that, we've got multiple agent workflows, right? So I think the two most common is like recursive or reflection, where basically you have an LLM give you an answer, and then you have the same LLM or another LLM acting as a different kind of like role, kind of review that answer and then modify that, right? So that's a really simple agentic workflow. But the multi-agent workflows that are appearing fascinate me the most, right? Because they have the greatest potential of creating the most sort of autonomous system, right? At this stage, though, it's going to be quite slow because, as you probably know, and if anyone who's played with LLMs, once you add an LLM to your workflow, your pipeline, that part of the process is probably the slowest part, right? You'll get tons of data from a database super fast. You get the question, you can provide the answer really fast, but waiting for an LLM to go through its thought process and come up with the answer, that part is still painful. So I guess maybe that's the second most exciting thing that I'm hoping will is that they will make smaller and smaller high quality models, or find a really fast agentic workflow that uses like really smaller but super fast models to quickly chain together answers and then provide really timely answers. That's what I'm hoping is will come out soon.
Awesome. Yeah, I think that just like what you said, the agentic kind of workflow field is going to be awesome this year. Like I think we're going to see a lot come out like this summer and onward. Everyone I know is talking about it and working on stuff around it. I think it's going to be really exciting. And even if it's like you said, can take a while for kind of these pieces with large language models together. It's cool. There's some cool use cases where I could go tell it to do something, but I'm not in a rush, like where I need an immediate answer. And maybe I come back like a few hours and see if it did like, a really complex task or something.
Yeah, and it might just be a need for people to kind of change expectations, right? Because we're used to like querying for questions, like in Google, and getting a fast answer, so that we ourselves are basically constructing the final answer that we want. But instead, move to like a kind of a fire and forget mentality. Like, okay, I need this thing done. I'm just going to set off this multi-agentic system off with a task, and then I'm going to go do something else. And when it's done, I come back and I can review it, right? So to kind of shift from like someone who's kind of on the front lines dealing with that particular research project, to kind of more of a moving everyone to kind of a higher level of like, okay, you're now more of like a director. You're like managing several AI systems to do things for you, to do a larger thing rather than focusing on these sort of smaller tasks.
Yeah. Yeah. I think it's going to be really cool. I'm very excited to see where it goes.
Yeah,
Um,
same, totally.
and is there anything else you want to shout out? I know we've already talked about you have a whole bunch of upcoming events, the Graph Academy. Any other things upcoming that maybe you didn't shout out yet?
Not that I can recall off the top of my head.
Yeah,
Um,
I think we got a lot just that came out from the other questions, so no worries.
cool.
One question someone had is if they asked if you could add any more comments on graph neural networks with Neo4j.
Okay. So this is slightly outside of my wheelhouse, and something I definitely invite people to look at our Graph Academy Graph Data Science courses, which talks about this whole. So there's this whole branch of mathematics that deals with graph theory and graph algorithms, and our own plugin, we call it the GDS plugin, uh, adds like 60 some, if I recall correctly, 60 some algorithms that you can use on your own data. And they have some interesting names, like the one that I first encountered was like harmonic centrality, which was a good way of page ranking. Um, uh, so I was using it to kind of match up different teams of people with various soft and hard skills of different degrees, right? Like, so doesn't know Python, is a expert in GitHub, moderate user of TypeScript, and then trying to match them up with a team that might have had a skill gap. So you can use, a GDS algorithm to basically suggest to you from all the data you have, like, oh, these three people are your top candidates to match according to that multi-point, valued uh, kind of rubric. So, anyways, yeah, many different algorithms available. Unfortunately, I don't know them all. It's not my specialty, but you can run these, and you can actually run an ML training pipeline right in the database using the GDS plugin. So yeah, definitely invite anyone interested in that to explore Graph Academy and our docs.
Yeah, that's awesome. That sounds like a great place to go, and you know, probably one of the better places to become like an expert in it right now, because there's not I don't think there's a ton of material on all this like newer stuff in like books or other courses and stuff. So Yeah, I think that's a really cool place to check out. Someone also asked a question about what was the query language you mentioned? I think it was like Cypher.
Yes. So Cypher was developed by Neo4j early on, and then it was open source. So there's an open Cypher version, which is meant for other graph database companies to also make use of. Now, just 2 weeks ago, the ISO standard for graph query languages came out, which is known as GQL. Not to be confused with Facebook's GraphQL, right, which is the REST alternative, right, which uses you can do basically nested JSON calls to get data in kind of a graph form. So GraphQL is separate. GQL, which is the ISO standard, is actually similar to Cypher. So Neo4j and several other graph database companies got together and kind of helped the ISO team in developing this new standard. So I have yet to work in GQL directly, but I do know that it borrowed a lot from Cypher. So even if you start off with Cypher, and because there's a lot of existing content on learning Cypher, it's still a good on ramp to GQL. You won't find jumping from Cypher to GQL like painful or dramatically different.
Awesome. And I know we're about at time here, or almost a little bit over. If people want to stay connected with you or ask you questions later, like we might not have gotten to everything in the chat today, what are the best places to do that? Probably is your LinkedIn, or Neo4j probably has a Slack type community.
Yes, so we've got Discord, so a public Discord link, which I'll give to you to post up as well too. So that's the best place to ask the sort of just general questions, especially if you're working on something timely. Otherwise, yes, LinkedIn is the best way to stay in touch with me. And let's see if I can join the chat here.
Oh yeah, you should be able to post a link in there.
Oh, it looks like okay. I've got to sign in first here. Allow.
I can also probably I think actually you might even already be linked in the description if I remember correctly.
Okay.
Someone did ask if we could send a link.
Okay, yeah, just connect with me over. So I sent it over private chat if you want to post that. So
gotcha. Yeah.
StreamYard wouldn't let me connect to the chat for some reason.
Yeah, give me 1 second here, and I will get that link and post it in the chat. Also comes up if you search for Jason Koo. I think you're always the top one there, but here's the link directly. And yeah, go check out all the Graph Academy stuff and all the live events that Neo4j is doing. If you want some people are asking, where do I get a demo, etc. I think Neo4j does a lot of stuff actually showing demos. Today is more of a casual fireside chat. So check out all the work that Jason is doing and Neo4j is doing around the area to kind of get more hands-on experience with Neo4j and graph databases.
Yeah, definitely feel.
Oh, sorry.
I was just gonna say, yeah. Anyone, just feel free to contact me if you want more information, and I can point you to various demos and stuff. We have so many.
Yeah, and go to the neo4j.com and go to that Learn tab, and there's so many good links in there to kind of everything that probably people would be looking for to getting started. All right. Well, with that, we're going to wrap up the stream. So I just want to say thank you, everyone, for coming and being very talkative in the chat today. It's always really fun when you're kind of hosting something and you see people are actually like engaging and answering questions and asking questions. It's really cool seeing that part of the community live in the chat today. So thank you, everyone who came out, asked great questions. Thank you especially to Jason for joining us live and answering all these questions. It was really cool. And hopefully it provided a little bit of insight for people who have kept kind of bringing up like how do graph databases play a role in LLMs right now.
Cool. Thank you, Sage. Thank you for having me on, and looking forward to maybe a Halloween project coming up.
Oh yeah, for sure. And potentially we might do some sort of other workshop together. So I know people in the chat were asking for demos and workshops. That's something like we're starting to do a lot more at Union as well. And I want to look at implementing a Neo4j RAG and using Union as the AI orchestration piece. So that could be a really cool workshop and project together. So everyone stay tuned for that. You can follow us on Union and follow everything or follow Neo4j for everything else that they're working on.
Cool. All right. Thank you, everyone.
I'm going to hit end stream. So bye, everyone. I'll hopefully talk to you all later.